Science would be nothing without evidence. The process of science involves coming up with explanations for things we see in the world that fits the data we've collected. If your hypothesis doesn't fit the data, it's time to come up with a new one. That's just how science works. Empirical evidence is information collected through observation or experiment. It's the heart of the scientific method because it's how we test our ideas. Scientists collect data and come up with an explanation for what they're seeing. For example, a scientist might see a rainbow and hypothesize that white light from the sun is being broken into each color by light refracting through raindrops. That explanation usually leads to certain predictions. For example, you might get a rainbow only when it's raining and when the sun is at a certain angle to you in the rain. Those predictions are then tested with more experiments, like looking for rainbows and making measurements about their position, or shining lights in a lab. Once enough evidence is collected, a scientific hypothesis becomes a scientific theory. Unlike in everyday language, a scientific theory is an explanation for something that is thoroughly supported by evidence and agreed upon to be true. So now that we know evidence is so important, how do scientists go about gathering data to support or refute their hypotheses? There are two main settings in which scientists gather empirical evidence: the field and the laboratory. Both have their advantages.